It's a great pleasure today to welcome you to Why We See What We Do by Bo Lotto. I would like to then just hand over to Bo Lotto and welcome to the Science Gallery. Thank you.
I'm going to start off, actually, with the conclusion, which is that science tells us that the colors we see don't represent the quality of light, but what that light meant in the past, okay? And it's the meaning that we see, okay? So what my work is about is sort of juxtaposing the physicality of light versus the perception of light. In a way, that's what this exhibition is doing as well. You have some exhibits that are looking at the physics of light, and then mine in particular that's looking at its perception. For the next 9 days, I'm going to be doing an experiment in the studio, in the gallery. So basically, I brought my lab, part of my lab from London to the gallery. So we're going to do an experiment, and the experiment is to try to teach bees to learn a concept, and that concept is going to be the darkest, the idea of the darkest. So there is no absolute darkest, it's a relational, a relative thing. So irrespective of intensity and color, they have to learn that there is a certain flower that has a reward and will be the darkest one. And the reason for doing that is to try to use bees as a way to try to understand how we see color. And if we can understand how we see color, which they do with just 1 million brain cells and we do with billions of brain cells, then maybe we can understand how we do all kinds of things, like sense of touch and sense of form. Okay? And what these towers are, these towers represent, each tower represents 2 minutes in time. Okay? And each dot represents 1/10 of a second. You can also trace the flight path of the bee, and this is a bee that hasn't learned yet. This is speeded up a couple of times. Right? And as you can see, as you go from tower to tower, the flight path becomes increasingly coherent as she learns the task. Right? And the task is actually quite a difficult one. The same bee, 6 minutes later, flies out of the hive, lands on a flower, and now she sits there and drinks the reward. Yeah. So,
exhibition sums up the use of light. It's amazing the way light is transported down these curtains. I just am so in awe of the artist that created it.
I'm Elke Harris, and this is my installation called 7 Drops in 7 Days. Colors change their appearance when another color is next to it, so basically this piece is always different. It's never quite the same because they all work individually and some work on random, so it's never the same art piece, it's always something completely different. Light shower 2, which reacts to sound, so you can actually stand inside it and just clap and then it will change the color. This one changes color automatically, and there's about 2 million different colors that appear, whilst I have one creation which is called the light shower, and people can actually go inside it and then choose the color they prefer. I think subconsciously you would just choose the color that you would need most at the moment to balance you out.
Great pleasure today to welcome you to Why We See What We Do by Bo Lotto.
Another question about color. What's it for? Here we have a jungle scene, and you see all the surfaces according to the intensity of light that they reflect. Okay, so it's a grayscale image. Now, can you find the predator that's about to jump out at you? If you haven't found it already, you're dead. The predator. There's a predator that's going to jump out of the screen at you. Can you see it? Can you? Really? How many of you can see it? Okay. Let's add the color now. Oh, yeah. All right. I get a sense that more people see it now than did before. All right. And for those of you that should have been selected out a long time ago, there it is, okay? So, right? So what are we seeing now? We're seeing surfaces not only according to the amount of light they reflect, but the quality of the light they reflect.